Okay, so in this video we're just going to introduce a couple of ideas. You can see I've kind of scribbled over a couple of the pictures, so if you just focus here for a little bit on this picture here on the left, we're going to assume that we have some kind of body. The shape of it really isn't relevant. Here we've got this kind of L-shaped member, but any kind of body where we have forces that are applied only at 2 points. So we've got one point A and one point B. Now this could be some kind of combination of forces, there could be a bunch of forces here, but those forces are all applied at this one point, A. And then we've got a bunch of other forces applied at this point B, okay? Now, if we are, we know that there's an equilibrium problem, that the piece is in equilibrium, then what we would maybe start with, let's say for example we don't necessarily know the directions of F1 and F2, okay? They could be in any old direction. Now if we want to know, find the equilibrium, let's go ahead and see, let's go and take the sum of moments about A, okay? Now for this to be an equilibrium, the sum of moments about A has to be 0, yeah? So now let's take a look at this picture here. So if we're taking the sum of moments about A, and if that has to be 0, then that tells us that the force, or the resultant of all the forces at B, F2, their line of action of those forces has to pass through A, right? Because if this force F2 was in any other direction, it would have a component here perpendicular to that line that joins AB, and this would result in a non-zero moment, right? And because we've only got forces applied at 2 points, if there's a non-zero moment, if there's a force applied at B that's producing a non-zero moment about A, well, there's nothing else to cancel that moment out, right? Because all of our other forces are applied at A, so they don't have any moment about A. Does that make sense? So what I'm saying is, if in order for the equilibrium here to be maintained, this force F2 absolutely must have its line of action along the line that joins AB. Its line of action must pass through A, yeah, in order for this to be true. See where I'm going? Now we can equally say, let's take a peek at the sum of moments about B. Now if we take the sum of moments about B, then the same has to be true going the other way, right? This force F1, its line of action must pass through B in order for this to be true. Okay, so what we have here is what we call a two-force member. So it has forces applied at only 2 different points, and what that tells us is that the line of action of both forces must be along the line that joins those points of application of those forces, A and B in this case. Yeah, and this is going to become really important when we look at two-force members. This is going to allow us to solve all kinds of problems that we wouldn't otherwise. We might have problems where we look and we say, well, let's see. Say for example, we had this here and we had a pin support here and a pin support there, right? Now if we're going to say, well, it's a pin, so we've got 2 components of reaction here, we've got 2 components of reaction force here, so that's going to be statically indeterminate, right? Let's apply some other force just so that we know there's something going on. For example, maybe we're ignoring the weight, but we've got a force applied here. Let's see. We know that the resultant of these forces, because we've only got forces applied at 2 points, we know the resultant of these support forces plus this applied force has to be along this line of action that joins these 2 points, yeah? And we know that these 2 components of reaction also have to have their resultant along that same line of action, yeah? So now, whereas otherwise the directions of these reaction forces at these 2 points would be unknown, we now know them because this is a two-force member, okay? So that's going to help us out. When we come to analyze trusses, basically trusses are structures that are just made up of a whole bunch of two-force members. So this is really important. This is going to be useful. Hopefully that makes sense. If for any reason it doesn't, let me know and we'll run through it. Okay? We also have what we can see as a three-force member. Now, if, as I say, for equilibrium to be maintained, the sum of moments about any point should be 0, yeah? So we've always, when we do these problems, we can pick what point we want to take our moments. So that's saying we can take any point, and the moments about that point must be 0. So here, if you took a look at this picture on the left, first of all, we've got 3 forces, A, B, and C applied. And let's say, for example, we know the directions of F1 and F2, right? So we can trace out these lines of action for F1 and F2 and see that those 2 lines are going to intersect at point D. Now, if we go ahead and say, let's take the sum of moments about D, well, that has to equal 0, right, to maintain equilibrium. And if F2 and F1 both have their lines of action passing through point D, then the moment of F1 and the moment of F2 about D is 0, okay? So that must mean the only force we have left is F3. So if F3 creates a non-zero moment about D, then we don't have equilibrium, okay? So for equilibrium to be maintained, the line of action of F3 must also pass through point D, okay? So that's what you see on this picture here on the right. So what we're saying is for a 3-force member, there will be a point where the lines of action of all 3 forces intersect in order for equilibrium to be maintained. So the way this helps us is that if we know the direction of 2 of the forces, we can automatically find the direction of the third, yeah? Because we know that where these F1 and F2 intersect, F3 must also, its line of action must intersect through that same point. So this can help us sometimes with certain problems to simplify them and to reduce them, the problems down. So have a think about that. Maybe when you're going through homework examples, see if you can identify some 3-force members and see if you can use this to help you solve those. And likewise, try and identify some 2-force members and see if that can help you in determining the direction of some forces.